So today I'm gonna go over some basics about UAVCAN. Now this is fairly new. It's only been around for about uh, 6-7 years. Right now the UAVCAN protocol is at a version 1. Now, so what is UAVCAN? So UAVCAN is like it's a high-level application bus protocol. It's for real-time intravehicular computing, and it stands for uncomplicated application level vehicular computing and networking. That's a mouthful. So the idea behind it is to have a masterless bus protocol. It's high level, abstracts complexity away from the user, and it's a publish, subscribe, or request response methodology. So if you're familiar with something like fast DDS, or it's a publish subscribe or ROS, you'll be right at home with UAVCAN, whether it be designing or using. The other implication of UAVCAN is its application level. So they're able to abstract a lot of information, a lot of the complexity away. So it sits on the CAN. It can sit on the CAN transport. I think there's also Ethernet as well. I've been experimenting with CAN on PX4 and the ArduPilot AP Periph libraries. So I have two nodes, and I've been doing some experimenting with one on the AP Periph, and the other one is using the PX4 CAN node. So who is the target audience? And so the target audience is really for designing is the vendors that want to create distributed computing applications. Whether it be like a gimbal, payload, something, sensor suite. You can put a lot of sensors on the CAN bus, right? And you've got the modularity, you've got the redundancy. There's no single point of failure because there's no master on the bus, right? So that's another implication is are the who's the target audience, and the users are obviously going to be the end application user, someone who's using the drone for a specific application, and it requires a sensor suite or requires type of payload or gimbal, and the idea is that UAVCAN is very reliable. It's immune to noise. UAVCAN uses the DSDL data serialization description language, which is it's going to be way advanced ahead of anything that any other kind of protocol for drones really, beyond maybe like someone's IP. So you're able to transmit these data structures over CAN and interpret them, right? So in UAVCAN, if you look at their Git repo, you can see the public regulated data types, which are pretty much like standard data types, right? You're not going to play with those; they're just there for you to use. And then the vendors can create their own custom data types, which is really cool. It opens the door for customization. And say, hey man, there's something in the standard data type set that's not suitable for your application. Well, you just go in and you create your own custom data types, right? Your definition files, and you just let the DSDL compiler do the rest. So yeah, just the data serialization. This is way ahead of anything on drones right now. It's leaps and bounds beyond what I2C can offer, and then you got UART, which is point to point. So you got so many wires. SPI, you have limited SPI ports. So UAVCAN kind of fills this untapped potential in vehicles, whether it be unmanned or not. The wider industry uses well-known protocols like ARINC, So this is a great interface to use, and I'm going to give an example of how I used one in PX4 for a rangefinder. I used a CAN node from M Robotics. It's the F303, and I just used the AP Perif library that they had, and yeah, I was able to get up and running pretty quick. So I'll go over that, and yeah, that does it for this. Alright, so this board here is the MRO CAN node F303, and I have the AP Perif library installed, the AP Perif CAN node. Got that plugged into my CAN port. So right now,
manual flight mode.
Yep. So that blue LED flashing. So PX4 does is it sets up a node ID allocation server, and the node dynamically gets a node ID from PX4, and then you're able to get out of bootloader once you have a node ID and you have a determined bit rate. So you have to get the node ID allocated, and then PX4 tries to determine the bit rate. Once that is determined and set, then you boot into the application firmware. So you wanna configure. So I have UAVCAN in the parameter search bar. I've enabled to 2, which is sensors automatic configuration. So that's the first thing. You want to enable UAVCAN on PX4. The other thing is you want to enable whatever device, whatever kind of subscription topic. So for mine, I'm using rangefinder, so I've enabled that, and I've set the range, max, and min. The next thing is you want to go into your Mavlink console or your NetX shell and type in UAVCAN status, and I'll show you what's on the bus. So in my case, I've got the node ID set up. So you should see online nodes at the very bottom, and so you're gonna find what your node ID is of your CAN node. So mine is 124. The status is okay, and the health is operational, or the mode is operational. So that means that, yeah, PX4 has picked up my CAN node. It's completely configured as far as the PX4 side. You can type in UAVCAN param list, then the node ID in the Mavlink console, and then I'll show all the parameters you can configure on that CAN node. So for mine, I've messed with some of them. So I've set the rangefinder type to 20. Rangefind1 _ type to 20. Then I've set the rangefind1 min CM and max CM to match the TF Mini Plus. The other thing I've set is I tried to set the orientation, but I've had issues with that. And then you want to go and disable whatever sensors you're not using on the CAN node or you don't have connected. So I've disabled like GPS, baro, compass, all that stuff. So since I have the TF Mini Plus connected and the rangefinder does show up in UAVCAN status and it has an instance number attached to it, I'm going to go to the Mavlink inspector, and you can see the distance sensor topic is there. And yeah, it's reading about 20 centimeters, which is right. So I've got that set up correctly, and I have that distance sensor set up for EKF2 range aid. And so I still have the primary height mode set to barometer, but within the ceiling that I've allowed, we should be able to use the rangefinder on pretty much takeoff and land to get a real stable hover, or a real stable takeoff and land. So that pretty much does it for setting up my CAN node, and I hope it was helpful.